Hi friends, hope you are doing well. Today I'm going to discuss some dark secrets of Fortran programming, and I have found some of these problems in many years as far as Fortran programs are concerned. Now, of course, you know that Fortran is widely used in many national labs, in universities, sometimes also in companies. There are legacy codes out there. These were written for modeling and simulation, specifically scientific programming. And there are many systems and subsystems out there for which Fortran programs are the key as far as simulation is concerned, modeling is concerned, and so on. So people nowadays put these codes in optimization loops. They put them in loops related to machine learning. Sometimes they may do robust design, robust optimization. But at the end of the day, you will find that the key variables which are being managed here, maybe it's to do with vibration, maybe stability of a system, maybe it is something to do with heat transfer, solution of differential equations. All these are being obtained from Fortran codes. So let us look at these 5 principles or 5 problems. Now the number one is the use of GOTO statements which actually skip large parts of code. And you will find every now and then some GOTO statement specifically labeled like GOTO 666 or GOTO 999. And you will see that essentially this GOTO statement simply skips a huge amount of code. So there may be, for example, a 50,000 line Fortran program, and you may find that there is a GOTO statement suddenly somewhere, GOTO 666, and it may skip maybe 1,000 lines of code and then it may go to some place there. Now essentially what may have happened at a certain time is that there was a part of code which was not necessary, but instead of deleting this part, instead of rewriting the program and so on, people essentially decided to skip this process. And frequently what happened is that every person essentially had a go-to statement which was labeled with his or her name, generally his name. So maybe there is go to 666 stands for a certain person, go to 999 stands for a certain person, go to 237 stands for a certain person, and so on. Now, of course, with the passage of time, many of these people move on, but the go to statement stays in the code. And it causes a lot of problem for anybody trying to figure out what the program actually does. Now the second fix which was sometime used is to do with a flag, and people would put a flag such as I flag and they would call it 1, 2, 3, 4 and so on, and depending on this flag different parts of the code would get used. And so every now and then what would happen is that maybe there are several methods out there in a code. In some place a certain matrix is being used, in a certain place a different matrix is being used, and depending on this value of I flag, the different parts of the code are being invoked. So essentially this was something which was known to the people who wrote the first program out there, or the people who were working on the first programs. But later on what happened is that these codes are lost. Sometimes people may know of the situation where they may use I flag 1, but they really do not know what I flag 2 does, what I flag 3 does, and so on. And it's very difficult to actually figure out some of these aspects of code. So keep this in mind. Sometimes these flags may refer to different configurations. So maybe there is a certain configuration of a system out there for which I flag 3 is required, and it was actually the right practice to have put all these in the input files, but very often people would not do that. They would hard code it into the programs out there. So this is one more problem as far as Fortran is concerned. Now the third thing you may find is some kind of factor, typically a numerical factor, sometimes called R, and this factor is used to control the convergence of nonlinear methods. So very often you have, for example, the solution of nonlinear systems. You have a Jacobian matrix multiplied by some number R. Now there is a scientific basis to this, that the Jacobian, when multiplied by a smaller number, sometime you can converge a nonlinear system through this, and if this number is large then it may diverge. Now essentially people figured out different values of this factor R. Sometime in the code you may find R1, R2, R3, R4 and so on. You will sometime find that some of these have been commented out and a particular value of R is being used, which is essentially leading to the convergence of the code. But it can happen that in different situations, maybe you are running your code for a different flight condition. If you are dealing with a flight simulation software, your code is not running, and the only thing you needed to do was maybe replace the value of r, maybe instead of r1 use r2. But again, these things have been hard coded inside the code, so it's very hard to figure out. Of course, you should remember that as far as classical Fortran is concerned, I, j, k, l, m, n refer to the int variables, and the remaining are the float variables. So very often this is of course taken for granted by people who are writing these programs. Now the next thing has to do with using the same variable for different things out there. So there was a general feeling that why create a new variable, for example, for solving any simple system also, such as ax equal to b. So sometime what would happen is that the solution itself would be stored in the variable x, and the vector b would be stored in the variable x in some situations, and so on. And the person who is writing the program may actually know what he's doing, but it would be very difficult for somebody to figure out as to what's happening here. And essentially, once the person felt that a certain variable had served its purpose, then the same value, for example x, is used to store something else. So this is something you will find in many Fortran programs, including those in the libraries, the numerical libraries. They essentially try to write very terse code with the minimum number of variables out there, so that the amount of memory they need to create in terms of the vectors, the matrices, is kept at a minimum. Now, while this can result in speedy code for scientific programming, it can be very difficult for many people to grasp. Finally, the next point has to do with a very clever use of int and float every now and then. So for example, there are some situations where if you were to divide a float by an int, for example, there is going to be certain math calculation which is going to take place. And if you think regarding this particular situation, you can figure out what the output is going to be. So for example, if I write a statement such as k equals f by I, then f is of course going to be taken as a floating point, I is going to be an int, and again k is going to be an int here. So when f by I is divided, you are dividing the float by an int, so this is going to be treated as a float. But then when you are storing it in k, again it's going to be truncated into an int. So all these kind of mathematical tricks were used in classical Fortran, and you will find them out there in different pieces of code. And of course, the person who did it, he or she knew how to do this particular problem, but it's difficult for people later to figure out as to what's going on. Of course, remember that in classical Fortran, I, j, k, l, m, n are being used for int and remaining are float. So that's the situation in many cases. So this was some concept about how Fortran programming is sometimes done. And this leads to a lot of complexity for people who are trying to figure out some of these codes out there. Remember, in many national labs, in many large companies, you have Fortran codes which are doing a lot of numerical simulation. In fact, they are being used in design of nuclear reactors. They are being used in aircraft design, in rotorcraft design, in ship design, and so on. So of course, Fortran is going to be there because it's virtually impossible to convert these codes to any modern programming language. And therefore, you may at certain point in your life need to deal with Fortran.